Hey guys, it's Joseph Rautenbach here, and joining me today is
The JiGiJee.
and we're going to be showing off our latest project, a real working calculator in Minecraft. Now this calculator can add numbers, it can't subtract or multiply, maybe that's our next project, maybe, we'll have to see. So it can add a 15 digit,
Yeah, can add 15 digits on both, or not 15 digits, 2
yeah,
digits.
not 15 digits, 2 digits. So
on both
yeah,
sides going up to 15, so the grand total can only go up to 30.
yeah, so each number could be 0 to 15 with a total of 30. Now, let's do a demonstration. The inputs are in binary, so if you don't know how binary works, right now in this example at least, let's say you want to get the number 11. You need to work out each switch here is labeled 8, 4, 2, and 1. So to get 11, you need to add up an 8, a 2, and a 1. So it's 8 plus 2 plus 1, that gives you 11. So you get an 8, a 2, and a 1. And that will make up 11. And it takes a bit of time to calculate. Remember, this is Minecraft. And then you get 11 plus 0 is 11. Now we can set the other number. Let's set that to 5. So that's a 4 and a 1. And we should get the result of 16. And it works.
As soon as it calculates.
Yeah, very slow, I know. And let's just try the maximum possible numbers, which is 15 plus 15. And we should eventually get a result of 30. Okay, and there are many ways we could improve this, but right now we're just going to show you the redstone. Okay, so as you can see, the back of the machine is pretty big, much bigger than the inside, of course. Now, Jans is going to be explaining, or yeah, as you could say, JiGiJee is going to be explaining exactly how the calculator works, basically right now. Then I can give a more technical description if anyone actually wants to listen.
So as you can see here, there are 3 layers, but that's not important right now. Right now you can just see here it's an input, where you press the buttons, it goes directly to screen 1, displays whatever you input, and then the second part goes to the calculator, the LU, which is this level that we're on right now, and then it works out the answer, and then that goes to screen 2, which is the top layer.
Yeah, the answer. So
that is pretty much the oversimplified version of what we did here.
Okay, so now, yeah, I'll give a more technical explanation. We have the signals from our buttons over here. You can see we have 8 redstone lamps, and those just indicate what state the levers are in if you actually want to see, which is fairly obvious. We have those signals come underground. Then they go to these binary to decimal converters, these long things here. These just basically convert the binary data that we get, the 4-bit binary, which is from 0 to 15, into decimal. So let's say we select 0, which is currently selected, then it gives this output. Now Jans just select 1 quickly. So he set it to 1, and now the second one is selected. Now set it to 2. And as you'll set it to 2, now the second one comes on. And this will carry on like this until 15. So then we've got all 15.
Okay, wait, let me just set it to 15.
Yeah, and then we go all the way up to 15. And that one's selected. So you can see how we convert that binary to decimal. It's a fairly inefficient way of converting. There are a lot more better ways to do it.
There are a lot worse ways too.
Yeah, a lot worse ways too. But this way, yeah, it works fine for us. And this is exactly why I'll explain why I did it in this next step. Now this is the actual 7-segment. I guess you could say this is the 7-segment decoder. So right now you have the inputs 0 to 15, and then you have this section over here. Now, as you can see, these 7 lines here, these actually lead directly to the display for the right digit. So you can see we've got 7 segments, so 7 redstone lines for each segment, and a segment is basically like, yeah, a segment is basically those part of the number that you'd see in a 7-segment display. And I'll show you on screen. You have 7 basic actual segments. You have A to G, so A, B, C, D, E, F, and G. So we've got these labeled here. This is segment A, B, C, D, E, F, and G. So what this device here does, this actually sort of, you could say, stores the font of each segment. So right now when 0 is selected, these redstone torches are turned on, and then this basically stores the font. So right now for a 0 you need every single segment on except segment G, with segment G being the middle. So as you can see now on screen, here's sort of a pattern showing where all of the segments are. And you can see now for number 1 as well, we have segments B and C turned on, only for number 1. But right now, as you can see, the binary digit 0 is selected, so everything else as a torch is disabled. So whatever binary number we put in, we'll get out the proper 7-segment value. And you see now Jans has selected number 1, so now this is showing the 7-segment digit for 1 right now. And then of course we have the 7-segment display. This is the part that actually gets all of those 7 segments and just displays it, you could say. We just have sticky pistons that either push in a block or pull a block. So I'm just going to go closer up to the display so Jans can demonstrate how it actually works. You can see as he changes between numbers, the blocks are actually going to be pushed in or pulled out. So there's a 2 and there's a 6. You get how it works. And here's a 14. As you can see, the 1 on the left, it's simply just, this is pretty much, there's only 2 segments for the second digit because it only goes up to 15. And now I'm going to be showing you the actual ALU. That's the actual core of this machine that does all of the calculating. So as you can see at the second layer, this is where the ALU is located. We have 2 inputs. Now these inputs are the 4 binary digits from the buttons. So we've got the 4-bit binary number from button B, the buttons on the right, and then here on the other side we have the binary inputs from buttons A, the group of buttons. So now with these numbers we can therefore calculate the added total by using a lot of full adder circuits. Now if you're not familiar with how this works, I'll put a few diagrams on screen showing the basic logic arrangement to do a full adder. And once you have a full adder has a input, B input, carry in and carry out. So that's if you want to add 2 1-bit numbers together. If you want to add more than 2 1-bit numbers, let's say here I want to add 4 1-bit numbers, then you simply just chain those full adders up together with each one's carry out going to the next one's carry in. So you chain them up together, then get all 4 of the inputs, and then for each one you get a carry out and a sum. And if you get each one's sum and you add it together, then those are the 4 bits. And then the final carry out is the 5th bit. So assuming everything is on, the 5th bit would also be enabled. So as you can see here, there's a lot of wiring. This is an incredibly inefficient way of doing it, because as you can see there are a lot of more compact versions that people have made, but we decided to literally build our own from the original schematics of the logic gate arrangement. This is not compact, this is directly using like direct inefficient logic gates in Minecraft.
Well, at least it's original, right?
Yeah, at least it's original. We built it from scratch, so we have complete understanding on this. Personally, I believe it's better because you understand now exactly what's going on, not just using some super compact circuit where you have no idea what's going on, how it actually works, unless you've totally studied exactly how the thing works. I saw a few of those circuits and I could not figure out how they worked. I probably could have, but I mean I didn't have a few hours to spend. And now onto the top part. So as you can see, I'll show you quickly. Here's the 5-bit output, 1, 2, 4, 8, and 16, and these 5 bits then go to the top section. The top section is the 7-segment decoder for the top 2 displays. So we've got 2 7-segment displays at the top. This is actually simply just a mirror image on each side, which is fine. And we've got we've actually got one big binary to decimal converter with a 5 bits. This is a very inefficient decoder, but it works fine since we only have 30 numbers, and we just wanted to get this done quite easily, understandable, and simply. So it's exactly the same as the bottom layer, using the same. Let's say right now the answer is 1, right?
It's 0.
Yeah, the answer is 0. So we have both segments to connect it up. As you can see, it's a mirror image, so the font is the same, but here's segment G. So yeah, for 0 everything's on except G, then just a mirror image on the other side, so 0, 0. Then for 1, it would show 0, 1. For 2, it would just show 2, 3, 4, 5 until 30. Then once you get to the 30th, which Jens is just going to try right now, then it's going to show 3 and 0. And otherwise, that's pretty much it. It took a while to do it. It took about 2 days, probably.
Yeah,
Not working all
not
day,
a full
every day.
2 days, but
Yeah.
still, yeah.
In hours, I'd say about 8 hours.
8? No, more than 8.
Yeah, maybe a bit more than 8.
The first day we worked like the whole day, more than 8 hours.
Yeah,
But
and
that included a lot of research.
yeah, so research.
There
were a lot of designs for these full adders and things that I were previously looking up, and surprisingly, many of them actually didn't work. And that's because in Minecraft there's been a lot of changes. Some relied on tricks like certain bug designs or things that no longer work well in newer versions of Minecraft, which no longer worked. And it was actually easiest to just build our own design, primarily because we knew it would work. We knew it would work because it does not rely on any glitches or bugs or... I mean, sure, there are versions that don't rely on them, but yeah, I mean, I get the understanding from scratch.
Yeah, well, except for the glowstone ladder at those areas, couple
yeah,
of areas.
Yeah, the glowstone ladders.
It should keep on working on to like Minecraft versions to come, pretty much.
Yeah, glowstone ladders, they work fine. I mean, it's a special property of glowstone that actually lets you sort of...
Well, that can easily be replaced if it stops working for some reason.
Yeah. Okay, so we'll provide a download link to the map in the description. You can test it out for yourself, and maybe later on we'll include more features like being able to subtract, maybe even multiply or divide. We'll just have to see. And of course, we could try with more accuracy, more digits, maybe even decimal places later on. Okay, thanks for watching. Once again, the map download's in the description. And yeah, I mean, this has been a really fun build for all of us. Hope you enjoy.
Sure.